Hello and welcome. I'd like to talk to you today about observable web applications, why you should have observability in your client-side, how client-side observability can better help you understand the whole of your system, and how to go about doing it. But when I say observability, what does that even mean? To me, observability means understanding the state and behavior of a software system without necessarily stopping it from running. We're not trying to attach a debugger in order to understand what's happening. This seems like a good thing to have. It lets us make better, more stable, more reliable applications. How do we apply this idea to a web application? Well, I'd like to use an analogy. Web applications are a lot like icebergs. Many web applications are small. You can kind of look at them, you can get your head around them, you can understand how they work. Like this website, notpoutine.fyi, which is a fun little website from a friend of mine that documents all these different foods from restaurants around the world, how they call themselves poutine, but how they fail to meet the simple test of them being poutine. That is, they contain French fries, cheese curds, and gravy. Most websites are much more complicated than notpoutine.fyi. But some web applications are huge, so big that one developer cannot hope to fully understand everything about it. For example, Target.com. Target.com is an e-commerce retailer in my area, and it does so many things. It does delivery, it does coupons, it does recommendations, it does order history, it does all of these things that are all different services, different systems running, and one developer can't possibly understand how it all works together. Related, this particular iceberg was a photograph off the coast of Canada, and I always felt that it looked like a giant ice monster flipping off the Canadians. But I digress. Regardless of what size web application you work on, they can all be treacherous to be around. Hidden bits in the application, weakened fault lines, and applications can break apart in unpredictable ways. They all have different skeletons they're hiding, different bits of code that maybe we're not the most proud of, that don't work 100% of the time. Some obviously take those skeletons more literally than others. But most importantly, web applications, like icebergs, have a lot going on below the surface. Only 1/8 of an iceberg's mass is visible above the water. And while that ratio of front-end code to back-end code might vary a bit for web applications, we all know that there's a lot of complexity hiding beneath the waves. Historically, observability efforts in a lot of companies have focused below that water level, understanding the myriad of services that make up a system. Their platforms, their performance, the activity and capacity, and all of those interconnections between them, tracing the calls, understanding dependencies, that sort of thing. And this is all super important to highly efficient operations. But ultimately, the user doesn't care about this. They care about what they see. And what they see is the client side. The users only see the client side of your application. It is the culmination of all the work that our systems do manifested in a UI. And whether we like it or not, this is all that most customers care about. They see that the search button is throwing an error, not that your inventory service is offline. The client side is also where most production issues get triaged. We see this if you've worked in a support team. Most web application bugs are reported to the client-side team first. The user saw an error on the page. And it's those web developers who are often responsible for triaging what was really going on and dispatching the work to other teams. Because users perceive our system here through the client side, observability in the client side gives us a better insight into the real user experience. And if we can get better observability in our client side, a bonus is that by observing our systems from the client side, we get a low resolution glimpse into what's happening below the water, what's happening in our service-side infrastructure. Server-side issues will manifest themselves as some sort of client-side problem. So the perspective where we monitor, where we observe our systems from, is super important. Let me tell you a quick story about a real system that I built that I think might illustrate the problem. So I was building a system, and we had a client side, and we had a bunch of services that went into delivering the capabilities. We were doing a whole platform as a service thing, using a bunch of native functionality in the cloud. And I wanted to build a status checker that would interrogate whether our services were online and performing at the rates that they should. So we built a little tool for that inside the same platform. And it worked really well. It was really easy. The trouble is that checking service, that monitoring service, ran on the same platform as the services. So it never had to leave that warm internal network of the cloud provider. If a network connection or DNS or SSL termination started failing, users would see that the system was down, but the checker thought everything was A-OK because it was inside of the network still. So that wasn't going to work. That didn't reflect reality. So we took that logic and we implemented it elsewhere. We moved it into a different service provider that could call in and make sure that their services were online. We even created multiple implementations of this in different geographic regions. But often, there are specific networks between our platform and our customers, which are different than the backhaul networks between different infrastructure networks. And so we would see the same problems manifest, where the other clouds would think that our cloud was online, but the end users would still see issues. So we took a different point of view. And rather than reporting when our services were offline from other unimportant, unrelated services, we decided to report when our services were online from the client-side perspective. As part of the client itself, it would interrogate whether or not the services were online and performing, and gather that information. And this was the only way we were able to really understand whether our systems were online and performing okay for our customers with a 100% relevancy rating, that if the check reported offline, a real user really had a problem here. So there's a lot of reasons that we should implement observability in our client side. The client side is paramount to the user. It's the triage point for most problems. And the symptoms of back-end issues will manifest themselves as client-side problems. Because of this, not only should implementing client-side monitoring and client-side observability be part of your application observability efforts, any sort of DevOps work that you're doing, I would argue that it's the most important place. It is the thing you should implement first, the thing that should be the most important part of your monitoring. So based on that argument, here's what we're going to talk about today. We're going to talk a bit about the general architecture of a client-side application and how they're likely to break. Then we're going to talk about the 3 techniques to better instrument our client side for failures: error tracking, performance monitoring, and usage analytics. Finally, we're going to look at what are the limitations of all of this. What are the limitations of client-side instrumentation for your application? Sound good? Let's get going. Before I dive in, just who I am. My name is Todd Gardner. I am what you would call a full iceberg developer. I'm from Stillwater, Minnesota in the United States. And you might know me from the things that I work on. I spend most of my time on 2 different projects. The first is Track.js, which is a JavaScript error monitoring service. And the second, more recently, is Request Metrics, which is a web performance monitoring tool. And we have fun sloth pictures that we put all over the web. If I say something or do something that you enjoy or maybe not, I'd love to know about it. Please take a photo or screen cap, tweet and share something that you think is interesting. Tag me, I'm at Todd H. Gardner on Twitter. This helps me understand what part of my presentation works well for you and what parts don't. It also helps promote me, promote this event, and promote everything else going on. All right, let's talk about the architecture of a client-side application. A lot of software developers will talk about microservices and how many microservices they have. No matter what your architecture is, you have way more instances of a client-side application than you ever will have services. Each visitor to your site is an entirely operational environment of your client-side application. And each of these environments is totally responsible for the end user experience of one of your users. Some of those users run on big hardware, on fast networks. Others users run on old Android phones, running on poor 3G networks in an elevator. But they all have the same general structure. They're all running inside of a browser. The browser is our runtime. Everything we do in our client side is managed by it, limited by it, and run by it. Within the browser, the most important part of what it does is render a user interface. We create HTML elements, styling, animations, canvas, click events, and transitions, all of these things that make up a modern web experience. And to that user interface, we need to make it functional. We need to interact over the network. So we attach network interactions to it. This is how we get all of our data, how we log in our users, perform our actions. We call all of the fine services that happen below the waterline. These are things like fetch, XHR, JSONP, WebSockets, and plain old HTTP requests. How we attach these two things is with our application code, which is also run within the browser's runtime. This is the JavaScript engine. On a super basic level, this is all that our application code is. We're gluing together UI events and network transactions, and vice versa. Sometimes we can even reach out to other client-side applications. We can embed third parties as our own application code, or attach iframes, or sometimes even do direct socket connections between two different browsers. These are all the really big components, and any of them can crack and cause problems for our users. For example, our application code runs as JavaScript, and JavaScript, as you might know, is not always the easiest language. It has some rough edges around async execution and understanding functional context and its ever-evolving syntax. Errors are inevitable, even for the most disciplined developers and teams. And when errors happen, the application code will break in sometimes interesting and non-obvious ways. The networks that we run on, we're not talking about our data center networks, we're talking about the flaky consumer networks. Networks are volatile, and many end users connect through networks that are slow or drop data, and sometimes they'll drop some of the data. Sometimes part of your application will load. 2/3 of your payloads will return, leaving your app in a weird, partially functional state. Worse, some networks manipulate data, adding or removing headers or injecting content onto pages. Third parties will often update their code and sometimes go offline, mostly without notifying you. When your integrations go down, does your application fall back gracefully? Users. Software would be so much simpler without them. Users will do odd and unexpected things sometimes. They might even manipulate their experience with browser automations and plugins that don't play with your code very well. Or maybe they just have never bothered to upgrade from IE9. And browser bugs. Browser bugs themselves are rare, but they do happen. More likely, it's a browser incompatibility issue that our code just failed to account for. There's at least 5 major browser implementations, each with subtle documented difference in their compatibility, performance, and API interactions. Since the user controls the client runtime, not you. You don't get to specify which browser they use. Many bugs are simply incompatible clients. So we have a complicated environment with millions of clients that can break in unpredictable ways. And yet this is paramount to our users. This is the user interface. So what do we do? Let's look at our different methods of observability of this fragile environment. We'll start with error tracking. What is error tracking? Well, I think that it's recording the unhandled exceptional states in our browser environment, application code, or network requests. As we've already looked at, the client-side ecosystem is complex. As some have said, it is the most hostile development environment imaginable. Errors will happen. Recording them and their trends allows us to understand the resiliency of our code. To discuss error tracking and other client-side observability tools, we need an example. So I'm going to craft one based on a company near me. This is MinnesotaPureClear.com. They make ice, really good ice. Those big clear blocks of ice for $15 cocktails when you just need a really good old-fashioned. Now, I have no direct connection to Minnesota Pure Clear. I just like their product. But we're going to use them as an example for client-side observability. Let's talk about their application. Their application operates both client-side and server-side, both above and below the water. Above the water, there are 3 core pages: the shopping cart, a product details page, and the checkout page. These pages depend on some services below the waterline that gives us some information about things: the customer API, the product API, and the orders API. There's even a third-party dependency here where they call out to Stripe in order to handle credit card payments. It's a client-side integration using JavaScript to punch out to Stripe and return a token when a credit card is processed. So how does error tracking plug into it? Unfortunately, there isn't a unified way that errors get revealed on the web. This has kind of been hacked in over the years as the surface area of the browser has expanded. There could be global unhandled exceptions, but that's not the same thing as a rejected promise, which isn't the same thing as a network request failing. Or sometimes errors aren't really errors, they're just somebody wrote a message into the console. Because of this, error tracking doesn't plug in super easily. We need to grab information from a bunch of different places. We need to wrap the browser to better understand its state. How do we do that? Here's an example. One of the places that we get errors is from the console. So somebody calls console.error. But there is no event I can listen to. I can't listen to console.onError or something like that. But we can wrap the function. Here's a very naive example of function wrapping. So we can take a reference to the function. Orig error is window.console.error. And then I can just redefine it. I can say console.error is now this new function. A function that takes some number of arguments, and now I can do things with it. I could save it, I could record an error, I could do other things with it before passing those arguments through to the original on-error function. I've effectively wrapped the function so that I can intercept things. An error tracking agent will use this sort of pattern. We'll add listeners and wrappers like this one. And when something exceptional happens, it can send off that data for analysis. Now, depending on what exactly you're doing, you might want to add additional context. Errors in JavaScript land are often terse and hard to understand. Combine that with very complicated client-side applications, and it can be difficult to really understand how did this error come to be. So when you're logging an error, consider adding additional context. Things like, what is the state of your application? If you're using something like React and you have a global state object, go ahead and just save the whole state. Tell me who the user is. Tell me what the session ID is. Tell me what they were doing. All kinds of things that you can bake into it. Now, once you have an error, you need to send it on to somewhere else to be captured and processed. Those could be your own services, like a metrics API that you build as part of your system. You need to, capture that error data and store it in some sort of data structure, and then do enhancements and deduplication and matching, and probably do some sort of reporting and alerting and all of those sort of things. Alternatively, there's a number of tools available in the space that help you, that can provide an agent in those services. I work on one such tool called Track.js, and I might be biased, but I think it's pretty great. But regardless of what you're using, let's talk about the errors themselves. What kind of errors are we talking about here? You all write great code, I'm sure. And it's not like there's bugs in your software. But error tracking will still catch things. Things like this. Here's an error that we should expect from the architecture of Minnesota ICE. Type error, stripe checkout is undefined. This sort of thing would happen on the checkout page, where that Stripe integration is coming in. And it would happen immediately upon page load, or very shortly thereafter. And probably impacts all the different browsers. Tracing the source code for an error like this, we would see some JavaScript that looks kind of like this. Here's a script tag where we're pulling in the third-party library, Stripe.js. And then as soon as that's done, we call stripe checkout.configure. Here's everything about my account and what I want to do. But stripe checkout is undefined. Well, how could that be possible? We just pulled down that Stripe file. But what if Stripe is down? What if the client network is unreliable? What if that API doesn't get created properly because of a JavaScript change? Well, the JavaScript is just going to blow up because Stripe checkout is undefined, leaving your checkout form in an unknown state. This error impacts a checkout page and can prevent users from giving money. Services, especially third-party services, are never going to be 100% reliable. We found a bug here in that our code didn't have a graceful fallback in the cases where Stripe is offline. Let's look at another example. Here's a common runtime error: unexpected token angle bracket. Minnesota ICE had this error on the shopping cart page, and the error tracking agent had the capability of telling them about other telemetry events on the page. So they could see that this error happened right after a network request call to /customers. If we trace the error back into source code, we can see that this error happened while trying to parse the JSON endpoint response. We create a new XML HTTP request, and when it completes, we are going to pass it into json.parse. We go ahead and send the request. So we're blowing up on that parse command. How could that angle bracket get into that JSON response text? Error pages. It is very common for APIs to be fronted with a web server, a load balancing server, some other thing. And when those are misconfigured or when those have a problem, they'll often return an HTML error page like this one. And what do those HTML error pages start with? An angle bracket. This error impacted an important bit of UI that showed that we have a bug that we need to handle errors more gracefully. It showed us a failure condition in our customer service as well. The service itself, the code running itself, is not the only bit we care about. And we need to watch all of the different load balancers and reverse proxies and all of the other bits between the service and the consumer. Error tracking gives you a better perspective into the completeness of your client-side application for your customers. It allows you to see browser incompatibilities, logical bugs in your code, failure to handle error cases, third-party service failures, and API availability. It gives you a real-time and historical view of which components are offline or broken. And what you should focus your debugging efforts on. But what if a service is degrading? It's slowing down, but it's not offline. Error tracking wouldn't really tell us that. What can we do? Let's turn our attention to performance monitoring to answer that question. When I say performance monitoring, what do I mean? Web performance monitoring is measuring the user perceived timings of network transmissions, user flows, and functions. The purpose of monitoring performance is to better understand the experience of our end users when they're interacting with our website. So how do we do that? Well, fortunately, we can plug into the browser, and modern browsers provide a really accurate set of APIs to measure performance, as well as all kinds of any custom timings, resource timings, load timings, API timings, all kinds of good stuff. And it's a lot easier than error tracking. We just need to pull down an agent of some kind. Again, this could be something built into your application, or maybe an external module, something from a third party. The agent doesn't need to be particularly invasive, since the browser itself makes all this data available to us easily. Network requests are automatically measured, and we can add additional custom measurements through an API. Just window.performance.getEntries will give us most of the things that we need. So an agent just needs to pluck out the bits of data that we want and send it off to our services. Those services could be that metrics API as part of your system. You need to store that data in a data structure and provide, some charting of performance data over time. Alternatively, there's a number of tools in the space to help you. I work on one called Request Metrics, which is trying to be a simple and fast way to understand performance. But what sort of things can we learn from performance monitoring? What kind of changes are important in web performance? The first kind of problem is just an overall slowdown in the load time of a page. For example, the Minnesota Ice checkout page has been slowing down over the past month. There's a lot of different users, and they don't all have the same experience. And sometimes that can be hard to understand. If you chart the performance of all the users, it's very noisy and it's hard to understand what exactly is happening. So it's important to see what the median data is, or what's the behavior of a normal user. It's also important to understand what most users experience, or the 75th percentile. And the 95th percentile tells us what the worst user experience of our application is. If we look over the past few weeks, we see that all of these things have been slowing down. All of the performance has been slowing down. This is a performance summary chart from Request Metrics. And over the past couple of weeks, that normal user has slowed from what used to be a 2 to 3 second page load time to now 4 to 5 seconds. And those worst users have slowed from 10 seconds all the way down to 20 seconds. Who would wait 20 seconds for the checkout page to load? So the checkout page is slowing down, and this is a really big deal. This is where Minnesota Ice makes money. This is where retailers make money. There's a lot of reasons it could have slowed down. There could be server delays. We could have added more or slower third parties, or maybe there's just too much JavaScript. But we do know that it has been slowing down from the user's point of view, and it warrants more investigation. Let's have a look at another example of a performance problem. In today's websites, there's lots of different ways that a website can be slow. One way is with a problem called layout shift. These are those annoying times when a page moves around and reshuffles itself as things are being loaded. Here's an example. So we have a page that's loading, and I want to click a button to do something. But every time I try and click a button, an ad pops in, or a display banner gets rendered, or something else happens. This is super common with like news sites and content sites, and they're very frustrating to deal with. We measure this sort of thing with a metric called the cumulative layout shift. It's the total number of shifts counted by the size of the pixel area that moved. Google defines this metric and has given us ranges for what good, improve, and poor ranges are. And we can see from this report that all kinds of users, the median, 75th, and 95th, are having a really poor experience on the cart page. This is usually caused by loading too much content asynchronously, or having excessive client-side rendering and not accounting for where things are going to be in the final page. Let's move on to the third component of client-side observability, usage analytics. This is where all of the data comes together. What is usage analytics? This is measuring the user traffic, movement, and actions through our web pages. Usage analytics is typically done from a product management or marketing perspective, but it's a valuable insight for everyone involved in web development because it shows us how people actually use the things that we build. Usage analytics doesn't really need anything from the browser. It's just some user code to send data to an API when something interesting happens. We rely on application code specifically to just tell us when something noteworthy has happened, when an event that we care about has occurred. It looks something like this. This might look very familiar from Google Analytics, which is one very popular one. This could be something custom, or it could be built into your code, or it could be a third party. The agent just really needs to provide a JavaScript API of some kind where we can send events like a page view, or a click, or a video watch, or my custom event. And we capture this event and send it off to our services. Those services could be that metrics API that you build as part of your system, storing the data and reporting it. Alternatively, there's tons of tools available in this space to help you. You're probably aware of Google Analytics, which is free, but gives Google a lot of information about your traffic and user privacy. Fathom is another one that's more privacy focused. And Cloudflare recently announced a free privacy-first analytics service. There's thousands more focused on different niches and points of view. But why should you do this? What observability questions does analytics answer? This is a marketing tool, right? No. The most important question that usage analytics answers is whether or not the behavior or performance of our web application is acceptable to our users. When something is changing, is that change good or bad? To discuss this, we need to talk about the funnel. Usage analytics tells us whether things are acceptable with a concept called funnels. We define the start of a funnel as an event, say landing on our page. And we measure all of the traffic that starts the funnel, all of the traffic that landed on this page. And the funnel itself is just one or more events that we want the user to complete on that page. Some users do, and we call these completions. These are the users that landed on our page and bought the product, or landed on the page and joined our mailing list, or whatever the funnel in question is. Other users don't. They leak out and they abandon the funnel. The ratio of completions to abandons teaches us how effective our app is at getting the user to complete the task. Let's look at an example. The checkout flow is super important for Minnesota Ice, as it is for all e-commerce retailers. It's comprised of a checkout page, an interaction with Stripe, and a server-side order service. Let's look at some analytics to see how well it's working. If we define our funnel as all of the traffic that lands on the checkout page, the other steps could be entering a payment method, providing a shipping address, or selecting a shipping method. Today, 25% of users complete the funnel and purchase what's in their cart. That's a little bit better than the average for their market. But the other 75% abandon their shopping cart and don't complete. So it's pretty good. Overall, I mean, it could be better, but it's pretty good. Now, what if things change? Earlier, when we were talking about performance, we saw that the checkout page has been slowing down. It used to return in less than 4 seconds for most users. But we saw in our performance trends that the page has been slowing down. It's now up to 10 seconds for most users. But it still works. It's still functional and people are still buying things. Is it okay? Should we fix it? The usage analytics funnel can answer that question. The checkout page funnel has also changed its ratio over time. Whereas it used to be 25% of people completed their cart, that has fallen to 12. Now, we don't know for certain that the performance change is tied to the funnel, only that these two things are correlated. And obviously, correlation is not the same thing as causation. The decline in the funnel could be market factors, weather, any number of other things. But if it was my money and I see that I've slowed performance and I've slowed my funnel completions, I think I'd call that slowdown unacceptable to my users and work on fixing it. There's a lot of great information that we can get from combining error tracking, performance monitoring, and usage analytics. We can understand where our application is breaking, when is it slowing down, and whether or not these things are problems that need to be fixed right now. But obviously, there are some limitations. This isn't a silver bullet that's going to fix all of your web development problems. I'd like to discuss some of these limitations. Number one, client-side observability tools, client-side monitoring tools, only work when there are clients to watch. When you are first launching your product, or when you're very time-based or seasonally based and nobody is online, you can't tell anything about your service if nobody's currently using us. For example, I can't report whether or not your services are online or not if there's nobody on your system to use it right now. Limitation number two. This is a particularly hard problem in the client side. Because you have so many different instances of browsers doing things, and they're all so different, they can be very, very noisy. We'll get lots and lots of data. Sometimes some of that data is unimportant, other data is very important. And we need tools to filter through it and understand what are the important things going on and what do we focus on. When we observe the client side, we have to balance that effort against user privacy. We can't collect everything about everyone without violating the user's expectations of privacy on our site. And this is especially important today with the rise of legislation in Europe around the GDPR and the Californian CCPA. We need to collect the information that we need to make our services better, but we can't invade the privacy of our users. Limitation number four. Because our users, our client side, isn't in the same place as our data center, the networks we run on and the geography is important. Sometimes we're going to have a bunch of really, really slow clients due to external network problems or geography. And you need to take that into account and be able to segment and filter by these things. For example, if your site doesn't cater to people from outer Mongolia, a bunch of traffic from there can create all kinds of trouble for your performance expectations. And you need to learn how to filter it out and focus on the people who are using your site that you've built the site for. Limitation number five. Most systems are going to have some service that don't serve the client-side application. They're a third-party server-side integration, or they're an availability check. Status endpoints, integration, webhooks, admin tooling, that sort of thing. And client-side instrumentation is not going to give you any visibility into the status of these. You obviously can't observe the client side of something that doesn't have a client. And finally, tracing services, especially if you have a complex microservice-based architecture. Tracing the interconnections of your services below the waterline is really important, but it's kind of limited on what you're going to be able to do from the client-side perspective. The client side can see when an endpoint outage is causing a problem, but not necessarily what happened downstream to cause the outage. And so traditional server-side logging and monitoring tools are still very, very important. So today, we talked about client-side observability and how it gives you a user-centric perspective into how your application works. I argue that it is, in fact, the most important part to observe in your system, as it reflects what users actually care about. We talked about error tracking to understand the exceptional states caused by service failures, incompatible clients, or just plain old bugs. We talked about performance monitoring to understand degrading services or user frustrations. And we talked about pulling it all together with usage analytics to understand whether our performance and errors are acceptable for our users. I spend a lot of time thinking and working on this topic. Most of my ideas are codified in the services that we build. Track.js handles client-side error tracking with a bunch of extra context and features like we talked about today. So errors know things like what browsers they're happening on, what pages, which users, inline code references, and all the things that the user clicked on or network requests happened before the error to give people a better understanding of how did this error occur. And I also work on request metrics, which provides an easy and understandable performance monitoring service. This is designed to be really accessible for developers on any size team to be able to use it with no training and be super affordable for teams of any size and any budget. This was Observable Web Applications. Thank you so much for coming and watching this. If you have any questions, any follow-up, please get in touch with me. You can hit me on Twitter @ToddHGardner or email todd@trackjs.com. Thank you so much.